All right, so let's begin reflection. This says, reflection is a transformation in which the object is flipped in a straight line called the mirror line onto the image. So here, a reflection is described as a flip, and literally it's like you have the shape on one side and you flip it in the mirror line. The object is flipped onto the image in the mirror line. All right. So here in the diagram here, you're seeing what a reflection would be like. ABC is the object, and B prime C prime is the image. ABC is the object, ABC is the object, and B prime C prime is the image. Please note that the point A is on the mirror line, all right, and later on we'll talk a little bit about that. Note also that the distance of A and B from the mirror line is the same the distance of B and B prime from the mirror line is the same. So the object and the image are the same distance from the mirror line. All right, so this is what a reflection would look like. And a reflection is a transformation in which the object is flipped onto the image in a straight line called the mirror line. So let's talk about some features of a reflection. All right, so here are some features of reflection. One, the mirror line is the perpendicular bisector of the line connecting corresponding points on the object and on the image. All right. I just said it real mathematical, real technical, real nice. But the long and short of it, it means therefore, you see the mirror line, the line that connects A and A prime, the line that connects B and B prime, the line that connects C and C prime. The mirror line is going to pass in the dead middle between these points. The middle line, so the mirror line will pass in the dead middle between A and A prime, B and B prime, C and C prime, and the two lines will be at right angles to each other. So in other words, the object and the image are the same perpendicular distance from the mirror line on either sides of the mirror line. The object and the image are the same distance from the mirror line on either sides of the mirror line. Ladies and gentlemen, the line connecting corresponding points on the object and the image is always at right angles to the mirror line. Feature number 2 about a reflection. Points on the mirror line are invariant. In a reflection, points on the mirror line are invariant. So under reflection, points on the mirror line do not move. So that means that the object and the image are the same point. So in the example we looked at before, triangle A prime, A, B, C became triangle A, B prime, C prime. You'll notice that the point A is both object and image. The point A is both object, so this is object, A, B, C, this is image, A, B prime, C prime. Note that A is both the same point on the what? Object and in the image. And that is because A is on the mirror line. So in a reflection, if a point is on the mirror line, it does not move. Now, this was not seen, you didn't see this in the diagram, but we'll show it. Two reflections in parallel lines is equivalent to a translation. Two reflections in parallel lines is equivalent to a translation. And two reflections in non-parallel lines is equivalent to a rotation. So I'm hoping that you'll see that in subsequent examples. All right, so let's move on to an example. So I'm guessing this is probably about example 4. Example 4a says, on the diagram below, draw triangle A prime, draw triangle A prime, B, C prime, the image of triangle ABC on the reflection in the y-axis. So the y-axis here is my mirror line. The y-axis is my mirror line. All right. Now, how do I do a reflection? Now, this is how I do a reflection. I use the fact that in a reflection, the object and image are the same distance from the mirror line on either sides of the mirror line. So I'm going to start with C. C is 1, 2, 3, 4 units on the mirror line. The image C prime would be the same distance from the mirror line, but on the other side. So it's 4 units. So C prime would be what? 1, 2, 3, 4 units. This would be the new position of C, and that would be what? C prime. How did I determine where C prime would be? I use this fact. In a reflection, the object and image are the same distance from the mirror line on either sides of the mirror line. All right, so let's remove those lines. All right, so it's 1, 2, 3, 4, 1, 2, 3, 4 on the other side. This is the new position of C. This is C prime. A is, you can see, 1, 2 units from the mirror line. A prime is the same distance, but on the other side, 1, 2. This is the new position of A. That would be A prime. Now, you'll notice that B is on the mirror line. In a reflection, a point on the mirror line is invariant, meaning it does not move. So that point B is both object and image. That point B is both object and image. So let's use our ruler and connect B and B prime to C prime to B, and connect. All right, that didn't do so perfect. All right, I have difficulty because I'm drawing on a tablet screen, but you should not have any difficulty. All right, then connect C prime and A. And lastly, connect A prime to B. Ladies and gentlemen, this is the object and this is the image. All right, what did I use in order to come up with the image? I use this fact. In a reflection, the object and image are the same distance from the mirror line on either sides of the mirror line. All right, can I just point out something before you move on? Note here, the point A in a reflection in the y-axis, that's how you would write it, because M is the symbol for reflection, for mirror. The point A, which was, sorry, let's use the point C. The point C, which was what, 4, 1. So C is 4, 1, this is C, became C prime, which is minus 4, 1. So what I want you to notice is that when you reflect something in the y-axis, the sign of the x-coordinate change, but the y-coordinate remains the same. So in a reflection in the y-axis, a point x, y is going to become the point minus x, y. So when you reflect a point in the y-axis, the sign of the x-coordinate change while the y-coordinate remains the same. The sign of the x-coordinate changes while the y-coordinate remains the same. That is what I want you to notice. You'll also notice it with A, which is the point 2 minus 2, should become the point minus 2 minus 2. This is A prime. And this is reflection in the y-axis. What do I want you to notice? Whenever you reflect something in the y-axis, the sign of the x-coordinate changes, but the y-coordinate remains the same. All right? Now I want everybody to do the same. I'm assuming that by now most of you would have done this already. You would have drawn your image, which is what? A prime, B, C prime. You'll notice that what B is on the mirror line, therefore it is both object and image. And the last thing I wanted you to note is that whenever you reflect something in a point in the y-axis, the sign of the x-coordinate changes while the y-coordinate remains the same. So everybody, please do the same thing that I just did.